So here we have a summary. 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 5,280 feet, or 1,760 yards. A year is 365 days, a week is 7 days, a day is 24 hours, an hour is 60 minutes, and a minute is 60 seconds. Was length and time, and then we also have capacity. Capacity is the same thing as volume, and then weight. Also in the book on the same page, so page 480 or 491. We've got those units of measurement. We're going to need to use those. Okay, a unit ratio. The unit of measure in the numerator needs to be the unit you want to convert to, and the unit of measure in the denominator should be the original unit you want to convert from. Okay, and then that makes probably absolutely no sense at all. But let's say you want to go from feet to miles. Okay? You start with the number of feet you have, okay, over 1. You multiply that by miles over feet, and this is the conversion factor. So this is the unit you want, that's the unit you had. Does that make sense? So you start with feet, and then feet would cancel when we do cross cancellation on multiplication. Feet cancel out, and you're left with miles. So, and we'll go over a concrete example of this. I just want to make sure you understand like the setup first. Okay, so I want to go from feet to yards. Okay, so I am starting out with 1,500 feet. And I just put that over 1. Whatever you start with, you always put over 1. And I'm going to multiply that by, for every 1 yard, my conversion factor is 1 yard is 3 feet. Okay. The reason we do this is because feet cancel. And then if you want, you can multiply straight across and then reduce. Or 3 goes into 1,500 500 times, and then multiply. So I get 500 yards. We're going to convert from yards to miles. So I have 9,240 yards. I'm going to multiply that by 1 mile, and in 1 mile there's 1,760 yards. Okay. Yards are going to cancel. Oh wait, there's supposed to be a 0. Sorry, I don't know what I did there. Okay, so if I cross-canceled this, or I could just multiply straight across. That's a mile. So it's 5.25 miles. And the reason it's miles is because that's the units that I was trying to get to. Okay, here I want to go from miles to feet. So I'm going to put miles on the bottom and feet on top. So it's, yeah. My miles cancel. And so then I do 8.2 So if you were to walk 8 miles, it's 43,000 feet. Multiply. All right. Here we're going to do multiple conversions. This is what I was talking about with multiple conversions. We don't have a conversion factor that takes me from miles to inches, right? So what I have is I have 0.25 miles. Now I know how many feet are in a mile, right? Mm-hmm. And I know how many inches are in a foot. Right? So I'm going from miles to feet and then from feet to inches. So what I'll do, my miles are going to cancel, my feet are going to cancel, and I'll be left with just inches. And I'm going to multiply straight across. My denominator is just going to be 1 at this point, so I can ignore that. And I'm going to multiply, move this over here. So my 0.25 miles times my 5,820 or 5,280 feet times 12 inches. So there's 15,840 inches in a quarter mile. Yeah, I can do inches to feet to yards. So I've got 22 inches. And I know that in 1 foot there are 12 inches. And I know that in 1 yard there are 3 feet. Now here I've got some numbers in the numerator and the denominator. So I'm going to cancel my feet and my inches out. And if I wanted to, I could cross cancel this 12 and 22, but you don't have to if you don't want to. You just multiply straight across. So you get 22. Here, hold on. You get 22 over 36, which will reduce 11/18 of a yard. Okay, so if you wanted to cross cancel, I'll do it in blue. And I'm going to leave out the units just for this purposes. Okay, if I'd wanted to cross cancel, 12 and 22 are both divisible by 2. So I'd still get 11 over 18. Okay. All right, so adding and subtracting units of measurement. You sort of treat this like the same way you would treat decimals.
That's what we do in Jamaica. Oh. You know, I've been here.
So we treat this the same way we treat decimals. A single apostrophe equals feet. Quotations equal inches, in case you have never seen that before. Okay.
You know, I learned that inches is 2 syllables.
1, yeah. So if I have 4 foot 6 inches and I want to add that to 2 feet 9 inches, I'm going to add my inches first. And that's 15 inches. Well, 15 inches is more than a foot, right? And 3 inches. So I have, if I took 12 away from that, that gives me 3 inches left, right?
Yeah.
And 1 more foot.
Yeah.
And then I take that foot and add it together, and so I get 7 feet. We might have to borrow.
Yep.
I have 8 feet 2 inches, and I want to take 3 feet 6 inches away from it. Well, I can't take 6 inches away from 2 inches, right? So I have to borrow a foot from that one. And a foot is 12 inches, so that makes it 14 inches. Does that make sense?
Yeah.
And then I can subtract 14 minus 6 is 8, and 7 minus 3 is 4. So I'd be left with 4 feet, 8 inches.
So it's not like you walk.
So, okay, after running a marathon, Dave crossed the finish line and noticed that the race clock read 2:20:30. We're going to convert this time to minutes. Okay? This is 2 hours, 20 minutes, and 30 seconds.
We're converting it to what?
To minutes. Okay? This part's already minutes. Part of it's done for us. Yeah. So we have our 2 hours. Yeah. There's 60 seconds in 1 hour, right? So that's, sorry, not seconds, minutes. Why do you guys let me say silly things? 60 minutes in 1 hour, so that's going to be 120 minutes, right? So that's this 2 hours done. Now we also need to do this 30 seconds. So if I start with 30 seconds, 1 minute has 60 seconds in it. So that would be 30 over 60, which would be 1/2, but I'm going to write it in decimal form. So half a minute.
45.
So I'm going to add up all of my minutes. So I have 120 plus 20 plus 0.5. So I have 140.5 minutes. So let's, customary units of weight. Weight records the force of an object based on gravity. That's why weight and mass are different, because mass is the same everywhere. Weight fluctuates. Like even on Earth, they average out that gravity is like 9.6 meters per second squared or something like that. But I don't actually, that might not be correct. But gravity here in Florida is a little different than, say, gravity on top of Mount Everest. So your weight changes based on how far you are from sea level. And then, of course, if you go to another planet, your weight is completely different. You know, if on the moon you weigh next to nothing, your mass is the same, but your weight is different because the gravity is much, much less. So, and then if you went to, say, a planet with really high gravity, I think Venus has really high gravity, or maybe it's Mercury. But if you go to a planet with high gravity, you would weigh a lot more. So weight has to do with gravity, whereas mass is constant. I mean, your mass can change, obviously, if you get larger or smaller, but not based on going from here to over there. Yeah. All right, so the average weight of an adult male African elephant is 12,400 pounds, and we're going to convert this value to tons. And from our chart, I have that 1 ton is 2,000 pounds. Okay, so I'm going to start with my pounds, and I'm going to multiply that by 1 ton over 2,000 pounds. My pounds will cancel, and I'm just going to multiply straight across on this one. And then I'm going to divide that. And I get 6.2 tons. Okay. Converting the weight of a 7-pound, 3-ounce baby to ounces. Well, I already have 3 ounces, right? That's already ounces, so I just need to convert the 7 pounds. And there are 16 ounces in a pound. My pounds will cancel. And I'll have 112 ounces, right? But don't forget this original 3 ounces up here. So I need to add that 3 ounces in. So the baby is 115 ounces. Metric system is decimal-based system of units. That means base 10. Okay. We have one basic unit of measure. We have meter, gram, and liter. So meter is length, gram is mass, liter is capacity. And everything's a power of 10. So, and capacity again is volume. Okay. This is in your book. This is section 8, chapter 8, section 2. It doesn't really show up. It's supposed to be right there. Okay. So, the meter is the basic unit of length. It's a little tiny bit larger than a yard. Not much. Just really small amount. Okay. This is the way your book shows the conversion. All right? So you can look at that in your book. I'm going to show you my version. Actually, you know what? Not yet. Sorry. It's a... Yeah, okay, I will. All right, you start with your meter. That's in the center. And then you build a staircase. Okay. And I just want to double check deci, centi. Okay. So I have going down the staircase, deci, centi, milli. As I go down the staircase, I'm getting smaller. As I come up the staircase, I'm getting larger. Okay. If I move down the staircase, I multiply by 10. If I move up the staircase, I divide by 10. So if sorry, I got that backwards. No, just the multiply divide. This one's multiply, this one's divide. So as I'm getting smaller units, my number's getting larger, right? No, I had divide here, didn't I?
No.
Okay, then I had it right. All right, as I'm going down, 1 meter is 10 decimeters, which is 100 centimeters, which is 1,000 millimeters. Like 1 meter is 1/10 of a decameter, because I divide by 10, is 100th of a hectometer, is 1,000th of a kilometer. So as I go up, I divide by 10. As I go down, I multiply by 10. So whatever you start with, if you start with deca and you need to convert to centi, you'd go times 10 times 10 times 10. If you started with deci and you wanted to go to hecta, I'd go divided by 10, divided by 10, divided by 10.
And you just add 1, 2, 3, 0, and 5.
Mm-hmm. And so, and every time you multiply by 10, you're moving one decimal place to the right. And every time you divide by 10, you're moving one decimal place to the left. So just for so if I have 2.68 decameters, how many millimeters is that?
Have 8.
So I start here, I have 2.68, 26.8, 268, 2680, 26800. mm for millimeters. This is deca. Yeah, this is, those are the two that are kind of confusing, deci and deca, because they're very similar. But so I started here. If I wanted to know meters, it would be 26.8. Decimeters would be 268. Then I'd get 2,680 centimeters, 26,800 millimeters. About approximating the distance in centimeters and millimeters. These are centimeters. So it's about 2 centimeters, right? I have 10 millimeters, 11, 12, 13, 14, 15, 16, 17, 18 millimeters, which would be 1.8 centimeters, which is close to 2. And as you can see, 1 inch is about 2.5 centimeters, not quite exactly, because here 5 centimeters isn't exactly 2 inches, but it's close. Just to give you an idea of how big a centimeter is. All right, I don't know why I put that in there. Okay, if I want to go from 10 kilometers to meters. Okay, I'm going up the staircase, right? I go deca. Nope, wrong way. Sorry. No, that's right. Okay, sorry. Hecta, deca, meter. So I'm going 3 steps, right? Hectometer, decameter, meter. So 10,400 meters. If I start with millimeters and I want to go to meters, I'm going up the staircase, right? My decimal starts here at the end. So this is centi, deci, meter. Right, so centimeter, decimeter, meter. That's my new decimal point, so it's 0.088 meters. And that was going up the staircase. So here, let me come back to the staircase real quick. So I had 88 millimeters, right? Which would be 8.8 centimeters, which would be 0.88 decimeters, which would be 0.088 meters. So I'm moving left 1 space each staircase, or each step of the staircase. Okay. All right. This is in your book. just talks about, it's basically the same thing I was just saying, just or moving decimal places rather than multiplying. But we already talked about that with our staircase, so. This is also in your book, same idea. This is important though. The decameter, decimeter, everything else is just km, hm, m, dm, cm, mm. But the decameter is DAM instead of DM, because decimeter is DM. So be sure to note that that one's different.
It's going to be D-C-A or D-E-K?
It's DE, oh, I misspelled it, didn't I? Yeah, it's DEKA, sorry. Okay. They're saying prefix line, we're going to say staircase.
Okay.
All right? I'm going from meters to centimeters. So I go down one step, that's decimeters. I go down one more step, it's centimeters. Okay, from centimeters to kilometers, I'm going up the staircase. I go up 1 to deci, up 2 to meter, deca, hecta, kilo. And of course you take the zeros off the end. All right, so we're going to have the distance from San Jose to Santa Clara is 27 kilometers. We're going to convert this to meters. So I'm going to start at, 26 kilometers. I'm going to start at the kilometers. Hepta, deca, meter. So that's 26,000 meters. Bottle of canola holds 946 milliliters, and I want to convert this to liters. So I start at the bottom of the staircase, and I'm going to go up. So I'm at milli, centi, deci, and then liter. So it's 0.946 liters. I have a bag of rice is 90,700 centigrams. You don't hear that a lot, but it is legitimate centigrams. And I want to convert this to grams, so I'm starting at centigrams and I'm going up 2 spaces, right? So centi, deci, and then gram, so it's 907 grams. Okay, cc's. 1 cc is equal to 1 milliliter, so if I have 0.5 cc's, I have 0.5 milliliters. So, okay, we are on 8.7, so we are in the home stretch. We are almost done. Quadrilaterals, perimeter and circumference, and area. Quadrilateral, that's just a fancy word for a 4-sided figure. Okay. So here's the definition of a quadrilateral. It's a flat figure, not 3-dimensional, flat, 2-dimensional, formed by line segments connected at their end, and that's a polygon, okay? So if I drew something, say for example, like this is not a polygon because it doesn't connect at the ends. It has to connect on the ends. And it doesn't matter. I could draw all kinds of weird, as long as it connected on the end, it's a polygon. I mean, it has a name, but you know. A quadrilateral is just any 4-sided figure. So the ones we're real familiar with, oh, wait a minute. Let's use my pretty tool. Square. Rectangle. Well, kinda. That's not a good rectangle. Rectangle. Parallelogram. Trapezoid. rhombus or diamond. And then this shape, not a triangle, is a kite. It's actually called a kite, and I didn't draw it very well. Let me go back to this. A kite has these two sides are the same length, and these two sides are the same length. And it's actually called a kite. The kite that we fly is named after the shape. So the shape existed first.
So the rhombus have equal sides.
Rhombus has equal sides, and the squares have equal sides.
So the rhombus is a diamond.
Yeah, but sideways.
A kite is not.
Yeah, rhombus is a diamond, a kite is, they're both diamonds.
Oh.
This is an equal-sided diamond, and this is a diamond that the top is equal and the bottom is equal, but they're not equal to each other. Alrighty, so we have, no, theirs are so much prettier than mine. Okay, parallelograms, opposite sides are the same length. That's what these little lines mean. And rectangle has 90-degree angles. They didn't mark it, but rectangles also have opposite sides of the same length. Square, 90-degree angles, and all four sides are the same. Rhombus, all four sides are the same, but the angles can be different. And then trapezoid. Okay. Perimeter, around the outside. You know, and in a circle, that's just the circumference. But you know, you hear in video games, my son likes to play, they're always like, guard the perimeter. Means like the fence on the outside, right? Okay. So we have formulas for perimeter. 2 times the width plus 2 times the length. Or if you don't want to memorize the formula, add up all of the sides. Okay, same thing with a square. Since all the sides are the same, it's 4 times the side, or if you don't want to memorize that, just add them all up. Triangle, add them all up. Circle is where it gets a little different. We have 2 pi r if you're given the radius, which is halfway, or pi d if you're given the diameter. And the reason that works is because 2r is the same thing as d. Right, because the radius is half of the diameter, so this 2 and that r become that d. Okay, questions on that? Okay, and this whole thing is in your book also. All right, so we're going to use the appropriate formula. I'm going to add this all up. So I have 4 feet 5 inches, 3 feet 6 inches, and 2 feet 8 inches. So that's 19 inches. Which I need to take 12 away from that, right? And put that 1 foot up there. And so that's 7 inches. And this is 5, 8, 9, 10. So around this triangle would be 10 feet, 7 inches. Using their formula, we would do 2 times 9 plus 2 times 6. Or if you don't remember that, you know that this is also 9 and this is also 6, right? So 18 plus 12 is 30. Oh, wait a minute. Why you let me lie to you like that? Inches, feet.
Oh.
So I can still do that, 2 times 9, but I'm going to need to do a little bit more work with that. I'm going to actually put my units in. Right? This is going to give me 18 inches, and this is going to give me 12 feet. But 18 inches is 1 foot 6 inches, right? So I'm going to put that over here. 18 inches is equal to 1 foot 6 inches. So I don't have 12 feet plus 18. I mean, it's not 12 plus 18. It's 12 plus 1 foot, 6 inches. So it's 13 feet, 6 inches. So be careful with that. So that you don't, so you know, notice that these were different. You still do the same, you still add up the 2 9s and add up the 2 6s, but you have to make the units. And if this had ended up being something like 4 inches, you would have had 8 inches, and you could just say that, oh, 12 feet, 8 inches, right? My radius is 1.6 meters, so my perimeter or circumference in this case is 2 pi r. So that's 2 times 3.14 times 1.6. Oops. 10.048 meters. All right. Area. Oh, we've all dealt with area before. You know, square feet. Yes, we will. Okay. So area is the square units enclosed within the region. So, like if you made a bunch of squares and these were all perfect and the same size, the area is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this area would be 20 square, whatever unit that was. So that would be 20 square units of this made up unit that I didn't draw very well, right? So if I have a rectangle, it's length times width. If I have a square, it's side squared, which is the same thing as length times width. It's just that the length and the width happen to be the same size. If you have a parallelogram, it's base times height. Now sometimes they are nice and they draw the height inside here for you. Sometimes they put the height out here. But the height is always to a 90 degree. Okay, so it can be that the height is out here. Also, they can draw it where this is the height and that's the base. But it's just base times height. Triangle is 1/2 base times height, and that's because if I put 2 triangles together, I get a parallelogram. And the triangle is half of it. Trapezoid is 1/2. You add the bases, these are bases, so it's the top and the bottom times the height. And then the circle is pi r squared.
So the radius, if it was 5, it'd be 5 times 5.
Times pi, yeah. Well, we'll go over some concrete examples. Good for you. All right, so we have a parallelogram, right? This is our height, this is our base, so it's base times height. So I'm going to say 1.8 times 0.6. And I get 1.08 kilometers squared. Okay. I have a situation like this where we don't want to know the area of this whole thing. We just want to know the area of the frame. So basically what I have is I have a large rectangle and a small rectangle inside of it, and the frame is the large rectangle minus the small rectangle. So I have 8 times 10 minus 6 times 8. Right? So the big one is 8 times 10. So the large one would be 80 for the whole thing. But then we're going to cut this out where the picture is, and that's that 48. 6 times 8 for this here. And so that is 32 square inches.
I was like, wait a minute. That's the way to know.
Okay. Area of a triangle is 1/2 base times height. Even though this is sideways looking, it's still a height, because a height is going to be perpendicular. So it's 1/2 of 16 times 7, right? My base is 16, my height is 7. So 1/2 of 16 is 8 times 7, so this is going to be 56, not centimeters squared. Okay. Now here I have a rectangle and a triangle. See that? So if this whole side is 11 feet and this is 9 feet, I need to know what this little part is right here. So I'm going to take that 11 and subtract the 9 from it. So that just this little part right here is 2 feet. Okay. So now for my rectangle, I have 5 times 9. So that's 45 square feet. That's just the rectangle. So I'm going to put R for rectangle. And then for the triangle, I have 1/2 of 2 times 5. So that's just 5, right? So the area here is 5 square feet. So altogether, this is 50 square feet total. Okay, so you have to, I don't have a formula for the area of a weird towery quadrilateral, right? I don't have a formula for this. This shape doesn't even have a name other than just quadrilateral. So we take it into its two parts. It's got a triangle and it has a rectangle. And I can find those two areas. Last two. We're going to determine the area of this gold medal. And what shape is this gold medal?
Circle.
It's a circle. And if my diameter is 7, my radius is 3.5 centimeters. Okay, and they're having us use 22/7 for pi. I don't care about that. Just use 3.14. They're the same thing. So the area is pi r square. So I have 3.14 times 3.5 squared, which is 3.14 times 3.5 times 3.5. Okay. So 3.14 times 3.5, not 35. 3.5 times 3.5. Now, granted, we don't have squares here, but it's still square centimeters. Well, because if you think about it, I multiplied centimeters times centimeters. So area is always squared. Whatever, feet, inches, miles, it's just always squared. Perimeter's not. And when you get into it, volume is cubed. So perimeter is just, let's say, inches. We'll just talk inches. Perimeter is inches, area is square inches, and volume is cubic inches. And if you think about that, it's easy to remember because like an ice cube has volume. Okay, I have this really crazy lawn, apparently. Just this weird, this is probably the shape of the house right there. It's some weird house shape, you know. So I have this rectangle, right? And then I have this thing. Okay. This thing that I have no formula for, well, it's a trapezoid, right? It's just a weird looking trapezoid. But I need to know, if this is 30, what's this length right here? 60, right? So the area of my rectangle is 40 times 90. But not. Okay, so that's the area of the rectangle. Now the area of a trapezoid is 1/2 of base 1 plus base 2, or, oh, sorry. Your book does A plus B, so I'm just going to do A plus B times H. 1/2 of 20 plus 60 times 30. So 20 and 60 are my bases. So that's 1/2 of 80 times 30. 1/2 of 80 is 40 times 30. So that's 1,200. Okay. So my total area is 4,800 square feet. And I want to know how many pallets of sod I need to buy in order to figure out how much it's going to cost, right? So I have to divide it. So I'm going to divide 4,800 by 240. Because that's how many square feet of sod are in each pallet. So I'll need 20 pallets. And then I need to multiply that times $225. So it's going to cost you $4,500 to sod this yard. Yes, it is.